So let's evaluate a system of linear equations in 3 variables. So say I give you, for the first equation, x plus 3y plus z is equal to 6. The second equation is 3x plus y minus z is equal to negative 2. Let's get that looking better there. And then the third equation is 2x plus 2y minus z is equal to 1. Now, for organizational sake, let's label the equations 1, 2, and 3. And the first thing we should do is to pick two sets of equations to cancel out one variable in both of those pairs. So it seems like the z is the easiest one to get rid of, and if we add equations 1 and 2 together, we'll be able to cancel out the z variable without doing any more work. So let's do that. Let's add equations 1 and 2 together. So equation 1 is x plus 3y plus z is equal to 6, and equation 2, we're just going to write it over. 3x plus y minus z is equal to negative 2. So now when we add them together, we get 4x plus 4y, and the z's cancel out, which is what we wanted, and we get 4 here. So now let's label this equation 4. That's a lot of 4's hanging around, it seems. So now we've got to pick another pair of equations, so we either pick 1 and 3 or 2 and 3. Now note, if we pick equations 1 and 3, the same thing happens as 1 and 2, as in this positive z is going to cancel out with the negative z from equation 3 once we add them together. So let's add equations 1 and 3 together. So equation 1, again rewriting it, 3x plus 3y plus z is equal to 6, and then equation 3 is 2x plus 2y minus z is equal to 1. So now adding them together, we get 3x plus 5y. The z's cancel out as we predicted and as we wanted, and then the constant term is 7. So now let's call this equation 5. So now note that equations 4 and 5 are a system of linear equations in 2 variables, which we know how to solve. So let's rewrite equations 4 and 5 over. So we got 4x plus 4y is equal to 4. And then the second equation is 3x plus 5y is equal to 7. So now we know how to solve these. We have to cancel out another variable. So generally you pick the variable that has the smallest number of coefficients, and it looks like the x variable would be the easiest to cancel out. Now note that if you multiply the first equation by minus 3, you're going to get a minus 12x here. And if you multiply the second equation by 4, you're going to get a positive 12x here. So that way when we add them together, the x's are going to cancel out. So let's do that. Let's multiply the top equation all by negative 3. So we end up getting minus 12x, and then minus 3 times 4y is minus 12y. And then minus 3 times 4, we get equals minus 12. And then for the second equation, let's multiply all the terms by 4. So 4 times 3x is 12x. 4 times 5y is positive 20y equals 4 times 7, which is 28. So now, adding these two together, the x's cancel out as we wanted. The y's are going to give us 8y, and then adding the constant terms, we're going to get positive 16, which is 28 minus 12. And so, since we got the equation 8y equals 16, we divide both sides by 8, so y is equal to 2. So now we have one of our solutions, right? So now, in order to find our second solution, we plug y is equal to 2 into either equations 4 or 5. And by doing this, we'll be able to solve for x. This is very similar to doing the two-variable case, right? So let's plug it into one of the equations, the first one. So we got 4x plus 4y is equal to 4. So I'm plugging it into equation 4 here. So doing that replacement, we get 4x plus 4 times 2 is equal to 4. That means 4x plus 8 is equal to 4. Subtracting both sides by 8, we get 4x is equal to negative 4, which means that x has to be equal to negative 1. So now we have our y and we have our x. So now to find our last variable, which is z, we got to plug x equals negative 1 and y equals 2 into one of the original three equations. So plug it into 1, 2, or 3. So let's look back at the original equations and see which one is the best to plug it into. So we got these three up here, and it seems like the ones that's going to give us the least amount of work is probably going to be the first one. So let's plug it into equation 1. Again, it doesn't matter which equation you plug it into. It should all give you the same value for c. So at this point, we're just looking for the one that's going to give us the least amount of work. So let's plug it into the first one. So plugging it into the first equation, which is x plus 3y plus z is equal to 6. So now let's just substitute. So x is negative 1 plus 3 times y, which is 2, plus z is equal to 6. So simplifying it further, we got minus 1 plus 6 plus z is equal to 6, or 5 plus z is equal to 6. And subtracting 5 from each side, we get that z is equal to 1. So now we have all of our three coordinates for our solution. So we have to write our solution in terms of the ordered triple. So you want to say the solution is x comma y comma z. So we got x minus 1 comma y, which is 2, comma z, which is 1. So that it's the solution.